All right, once we get the same base there, we can drop that base, okay? So now you're gonna distribute that, it's gonna be negative 3x plus 6, right? Because negative is gonna be equal to 8. So then solving that, you minus 6 divide, you should get negative 2/3 there. See if you can do that next one, log. So first thing on that letter B is I'm gonna do something with that 3. What do I wanna do? Bring it out front because I can do that with logs, then I can divide by it. Bring it out front, then I can divide by it. Again, we're just kind of practicing. We're gonna do that last one down there also. So if I do bring it out front, I got log 3 log base 5 2x minus 1 equals 21. Now I can divide by it. Divide both sides of the equation. Log base 5 2x minus 1 is equal to 21 divided by 3 would be 7. So now I've simplified the log. I'm ready to write it in step 2, I'm ready to write it in exponential. Write it in exponential, you might want to grab your calculator out because it's going to be a big number. So what is it going to be exponentially? What power? 5 to what? 5 to the 7, okay? Is equal to 2x minus 1. So you got a little work to do. So grab your old calculator, see if you can get 5 to the 7th. I probably need to add 1 then. So I'm going to add 1 to that side, then divide it by 2. So you can get 39,063. So again, just practicing some calculations there. Everybody okay? See if you can get that last one. It's different than letter A. The last one is still exponential, but I can't get the same base. So what am I going to do? Take the log of both sides. So grab your calculator again. See if you can follow and get through that one with the log of both sides. Once I do that, I can bring the x minus 2 out front. I still have log 13. I can bring that 3 out front. I still have log 36. What am I going to do next would be divide by log 13. So it really becomes a calculator problem now. Log 36, hit enter, divided by log 13, hit enter. Multiply it by 3. And then you're going to need to add 2 because we still just have x minus 2. So you're going to need to add 2. See if you can get 6.19, some change there. So log 36, enter, divided by log 13, enter, multiply it by 3, and then add 2 to it. How are we doing? Are we okay? So we did a couple, 2 exponentials, one we got the same base, one where we didn't, and we did 1 log. Feel okay about those? From yesterday, we spent 2 days, we've done a couple sets of homework with it. We did yesterday, was it 7 rounds yesterday? I know in nature, you're supposed to, hopefully put that in. I had the answers up there. Hopefully you did them and checked yours. We're ready. Is everybody okay? We're ready to move on to the last section of logs, which you should be excited about. We will have a short quiz next week over 7576. We'll have a practice on Monday, and then whatever day you're in here, whether it's Tuesday or Wednesday, we'll review that day. Some of you might be in here Tuesday, some of you might be in here Wednesday, depends on which day you're taking the ACT, okay? You're taking it one of those 2 days, either Tuesday or Wednesday. The makeup day is Thursday. We'll probably do a little review, and we'll have an assessment probably on Friday of next week. A little bit, oh no, we don't have school Friday, right? Next week we don't have school. We'll have it on Thursday. We'll be having an assessment on Thursday over 7576, okay? All right, today is the natural log, okay, base E. If you look on your calculator, there's an ln somewhere, find it. Should be around your log. We've been using log, okay? And we also know that log was base 10, right? But we didn't write base 10, we just wrote it as log, right? Well, ln is base E, so that would be log base E. We don't write log base E, we write just ln. Now, what is E? Well, E is a number, okay? E is used to calculate continuous growth. It is approximately 2.71 with a bunch of change. It is the second most popular irrational number we use. What's the first? Pi. So E is an irrational number. So if you have your calculator there, go second ln. Does it say E and it have a caret? Put it to the first power. Hit enter. 2.7 and some change. Okay, so that's kind of what E is equal to, somewhat. Just like when you were in grade school, what did you say pi was? 3 point? Well, we know that's not really the case, is it? So E is around 2.71 and da-da-da-da. What is it used for? Calculating continuous growth. Okay? Now, we need to learn how to handle some ln problems, some log problems. So we need to simplify some. Okay? It is called the natural log because it happens in nature. It's used what? For continuous growth. So natural log, we have the common log, which is base 10. Now you're gonna have the natural log, which is base E. They're both in your calculator. ln is base E. Make sense, everybody? All right. There's a bunch of other stuff about it, about graphing, which we really haven't hit that much. It is an exponential. I am not going to make you graph anything, okay? It is approximately what you just put in your calculator. It isn't irrational. The second most used irrational besides pi, okay? So there's approximation for it. And you're never really gonna need to do that because you have your calculator to do those tasks for you. Okay, here's some more about its inverse. We've talked about inverse earlier, okay? So ln is the inverse of e to the x, not something I'm going to make you write down or give me back. Is that clear, everybody? Okay? What we do need to be able to do is simplify some logs. Now, one thing you need to know, think about this. If I had log base 10, 10, okay, or if I just wrote it as log 10, I'm hoping we all know that's 1, right? Okay? So if I had log base E, what would that be? 1. Well, we don't write it as log, we write it as ln E. So if I see ln E anywhere, what's it going to be equal to? 1. Okay? And that's your main thing for today, folks. How about that? observed the performance yesterday. It looked pretty good.
Thank you.
Man, lots of energy. It looks like fun.
Yeah, it's so fun.
All right. So, of course, we can rewrite this as same properties hold true. 0.15 t ln of e. Right? It's a log, so we can bring that puppy down. He's out front. What's ln of e equal? So what's this thing simplified to? Just that, doesn't it? Shut up, boom, shut up, bang. So, what are we trying to get? Well, I'm trying to get ln of e, so I can make it 1, or I'm trying to get e to the ln. That too is also 1. E raised to an ln, that too is also 1. With that being said, what do you think letter B might end up being? Well, I got that 3 is a problem, but it's in front of an ln, isn't it? It's in front of a log, so what can I do with it? E ln of x plus 1. I can take it back up, can I? Yeah, I can do that with logs. I can move it back and forth. So now, what do I end up with? Well, I have e to the ln, so guess what? That is 1, so my whole thing just simplifies to what? Boop. X plus 1 to the third. We're looking for ln e to simplify, and we're looking for e to the ln to simplify. How we do it? This takes a little practice. What do you think here? Well, I can bring the 2x out front and have ln of e, plus I can bring the x out front, have ln of e. What's ln of e equal? 1. So really, I'm basically down to 2x plus x. How we doing? Same all the stuff we've been using, just different little letters. Ready for a couple more? A couple people still noting? Ready? You might be able to roll through these pretty quickly. Just write the problem down, write what you think the answer might be. That's what I would suggest. These are lookers, in my opinion. Look at it and see if you can get it. We'll peel back a few answers, see how you're doing. Should be 3.2, right? Should be what? Careful there, it should be x squared, okay? So to get e to the ln, we need to bring that 2 up, so it's gonna be e ln. We can bring that 2 back up to the exponent. So now we have e to the ln, so we got x squared, okay? They have to be beside each other. Next one's pretty easy, isn't it, letter C? It's already, I can't make that one much easier. What do you think here? Real simple for that one. What's it gonna be? Come on, somebody be brave.
X squared.
Huh?
X squared.
Two x, okay? So x, it's going to be ln of e 2 times x. The other options, you can bring the x down front, you write it as 2x ln e. All right, back to that thing. Does everybody understand that ln e is the same as log base e, which would be the same as log base 10, which is the same, maybe log base 5, whatever. Does everybody see that? ln e. Anytime you see ln, that's a base 10. Oh, now we're gonna have some equations. We're gonna do the same things, okay? After pull my britches up a little bit. Now, come on, britches. Man, I got the flood going. Woo-hoo. All right, step one, I gotta write it in what? Single log. So it's gonna be ln of x over 7 equals 4. Step one. No different than what we've been doing, right? Minus, so we divide. What was step two? Put it in exponential. Now here's where things get a little different. Because what is our base here? Our base isn't a number, our base is a letter, which is a number. It's e. I'm going to rewrite this as e to the 4th equals x over 7. Very crucial. We're converting that ln, which is base e. Does that make sense to you? So e to the 4th. We don't have x by itself yet. What's keeping it at 7? So what do we need to do? Multiply both sides of the equation by 7. So we're really getting x is equal to 7e to the 4th. I mean, the good news is we're doing the same stuff. We just have ln involved. What is ln? Base e. ln e is 1. E to the ln is 1. All right, see what you can do with that next one. Plus sign, so how do we combine those? Multiply. ln 10x to the 4th equals 16. Now I could write it in exponential, but it'd save me a little bit of time if I bring this 4 out front and then divide by it. So I'm down to ln of 10x, 16 divided by 4 is 4. Still okay? Now what? Write it in exponential. What's my base? E. So it's going to be what? E to the 4th is equal to 10x. Exponential. Still a little bit of work left to get x by itself. What are we going to do? Divide. Okay. And that would be e to the 4th divided by 10. X is equal to e to the 4th. Now, we're going to leave it as e. We're not going to go in our calculator, put e to the 4th and divide it by 10 and get some nasty decimal. Just like sometimes when you did circumference, you would leave it as, oh, it's 3 pi, right? Or the area, sometimes the area you would say 5 pi squared, right? So since it's an irrational, we leave that thing go. All right. simplifying, ready to move on to this guy right here. Amount is equal to my starting principal, E raised to the rate times time. This is gonna replace amount after time is equal to my initial amount, 1 plus or minus my rate, raised to the time. It's gonna replace that, okay? This guy up here, continuously compounding. That's all you need to remember. And you need to think about that. P-E-R-T is used every day, constantly. That's what really uses. Not many are using this guy. They just don't. Because that is the way to go. It is calculating continuous growth, continuous compounding, continuous decay. And it's a much easier little formula for us. So I know P stands for principal, but it also stands for just kind of your initial amount. You could also use this for other things too, but this is compound continuously. Grab your calculators, let's just do 2 of these and then we're gonna call it a day. Is that fair, everybody? I would just definitely have P-E-R-T. Perk. When I was a kid, I had a shampoo called Perk. It's green. Anybody ever seen that shampoo? It's green. Yeah. You might see it in Ollie's up on the shelf in Ollie's, you know. You ever know, we know where Ollie's is by Chipotle there, where they have stuff that, you know, no one wants anymore and you get it for half the price or less than that. So, Mrs. Grove and I like going in there and walking around sometimes. But I never buy food there. You never buy food there. Yeah, it'd be like getting sushi from a gas station, you know. It'd be not good. So, all right. These are all pretty quick calculators. So grab it. Initial amount 500. Find your E, which is second ln. It should give you a caret when you do that, does it? Okay. Does it give a bracket too? Okay, you might want to put a bracket then. Okay, we're going to take 40 times my rate. Of course, we got to break that as a decimal. 0.0525. Hit enter, and you should get. Let's see, how much should you get? Not that much, I don't think. Yeah, $4,000. That's 40 years though. That's a lifetime. That's a generation anyway. So you can get that $4,083.08. Good. One more of those. $100. Let's take a quick practice. 100. Find your E button, second ln. 8 times. Make sure you put your rate as 0.035. I don't even know. 133, I think, somewhere around there. Is that it? 132? I didn't think it was much. How we doing, my friends? Everybody good? Feeling all right about things? Okay? Everybody feel okay about that? It's pretty simple, isn't it? Every year a student says, where's E? So does everybody know where E's at? Second ln? Make sure you use your practice there. All right. We are not going to do that. We are going to head towards this guy right here. Thank you very much.
Mr. Grove, do you want to see something cool?
I do. I always like seeing cool stuff.
Yesterday,